firefighting. Firefighting means to control and extinguish the unwanted fire. Fire can be controlled by removing one or more of these conditions required for combustion to take place. The firefighting operations work mainly on two principles: bringing down the temperatures of the burning substances below their ignition temperatures, cutting off the air supply to the burning substances. Water as a fire extinguisher. When a fire brigade arrives, the firemen extinguish the fire by throwing water under pressure on the fire. Firemen extinguish the fire by throwing water under pressure. When water is thrown on the fire, it cools the combustible substance below its ignition temperature, and this prevents the fire from spreading. The water, when heated by fire, forms water vapor, which also surrounds the combustible materials, helping in cutting off the supply of air. So the fire is extinguished. Thus, water is very effective in firefighting operations. Water cannot be used to extinguish fires in electric wiring caused by electrical short circuit. Water cannot be used to put off fires caused by burning of oil or petrol, because water, being heavier than oil, settles down at the bottom. The oil floats over this water and continues to burn. Carbon dioxide as a fire extinguisher. Foam type fire extinguisher. The foam type fire extinguisher consists of a metallic cylinder having a knob and nozzle tube. The metallic cylinder is filled with a saturated solution of sodium bicarbonate. A glass bottle containing aluminium sulfate is kept inside the metallic cylinder. Knob, aluminium sulfate, nozzle tube, metallic cylinder, sodium bicarbonate plus saponin, nozzle, foam type of fire extinguisher. This fire extinguisher can be safely used to extinguish fires caused by electrical appliances and inflammable substances like petrol and kerosene. Taking care of fire victims. We should immediately bring out the fire victim from the fireplace to an open space to prevent the fire victim breathe harmful gases like carbon dioxide or smoke, which can lead to suffocation and breathlessness. When the clothes of a person catch fire, the person should be covered with a blanket to cut off the supply of air. Hence, the fire gets extinguished. Blanket wrapped around a person whose clothes caught fire. Flame. A flame is a region where combustion or burning of a fuel in its gaseous form takes place. All the gases like LPG, which undergo combustion or burning, produce a flame. So, only those solid fuels like wax, camphor, etc., which vaporize or form gases on heating, burn with a flame. Liquid fuels like kerosene oil, mustard oil, etc., which vaporize or form gases on heating, burn with a flame. Zones of a candle flame. The innermost zone. This zone lacks oxygen of air, and hence, in this zone no combustion takes place, so it appears black. It contains unburned wax vapor. The innermost zone is the least hot part of the flame. In other words, we can also say that the innermost zone is the least hot region of the flame. Middle zone. The middle zone. In this zone, there is not enough air for complete burning of the wax vapor. The partial or incomplete burning of the wax vapor produces carbon particles and carbon monoxide. The carbon particles become white hot and emit light. So, it is the glow of hot carbon particles which makes the middle zone of a flame luminous or light-giving. These carbon particles then leave the flame as smoke and soot. The middle zone of a flame is not hot. This zone is the major part of the candle flame. Outer zone. In this zone there is a plenty of air around it, so complete combustion of wax vapor takes place, producing carbon dioxide and water vapor. It has the highest temperature in the flame. In other words, it is the hottest zone of the flame. The flame appears blue. The outermost zone is quite thin and non-luminous. Fuels. The materials which are burnt to produce a large amount of heat energy are known as fuels. Wood, coal, LPG, kerosene, diesel, petrol. Classification of fuels. So, fuels are classified as solid fuels, liquid fuels and gaseous fuels. Solid fuels: coal, coke, charcoal, wood. Paraffin wax are solid fuels. Liquid fuels: kerosene, petrol, diesel are liquid fuels. Gaseous fuels: natural gas, liquefied petroleum gas, LPG, biogas, compressed natural gas, CNG are gaseous fuels. Characteristics of an ideal fuel. It should be fairly cheap and easily available. It should be easy to handle, safe to transport and convenient to store. It should burn smoothly. It should have a high calorific value. It should not produce any harmful and irritating fumes during burning. It should not leave ash, residue after burning. It should have a proper ignition temperature. It should not be too low, like room temperature, or too high. Calorific value of fuel. Calorific value of some common fuels. Fuels, calorific value. Cow dung cakes, 6 to 8 kilojoules per gram. Wood, 17 to 22 kilojoules per gram. Coal, 25 to 33 kilojoules per gram. Biogas, 35 to 40 kilojoules per gram. Diesel, 45 kilojoules per gram. Kerosene oil, 48 kilojoules per gram. Petrol, 50 kilojoules per gram. Natural gas, 32 to 50 kilojoules per gram. CNG, 50 kilojoules per gram. LPG, 55 kilojoules per gram. Hydrogen gas, 150 kilojoules per gram. Burning of fuels lead to harmful products. The burning of fossil fuels like coal, petroleum, diesel, wood, etc. produces various air pollutants like carbon monoxide, carbon dioxide, oxides of sulfur and nitrogen, unburnt carbon particles, etc., which cause severe air pollution.